Well, as this video is going to go through 2018 higher level short questions, we'll start with A1 there. The 3D graphic shows a bicycle shelter. The drawing shows an incomplete diametric projection of a similar shelter using the axonometric axis method. The horizontal plane is also included. Part A, complete the axonometric projection of the bike shelter. So the first thing we need to do is draw out the outline of the actual bike shelter itself. So we can see all lines coming from like our elevation here are taken at this angle, and our lines for end view are coming in at this angle here. So make sure to keep all our lines parallel. I'm going to start off with this outline here. So basically these three lines, they've already set them up there for us. So I'm going to start off with those. So the first thing I'm going to do is take in 2 points on the ground. So you can see there it's going to be this one and this one are on the same line. And then I'm going to take in the next one here. And then finally the top one. I'll leave out this line here for now. I'll just focus on getting these three here. So they're taken in from the right. What I need to do now is take them in from the left. So on the ground there, there's my front point. On the back, there's my other ground point. And then I have my two more points here and here. There's my front one, extended in there. So just follow it over. That's it there. And then my back one, extend that across. And that's going to be this point here. Sorry, the front one should be higher up. Should be this point here, because I'm taking the top. So then what I have is, I have this line here, this line, and finally this line here. I can then connect these together, join my roof, like that there. And then finally I have my line going across, and that can be found very simply by taking these 2 points across there and there, and you'll see that these work out to be parallel as well. So that completes the actual outline of the bike shelter. The next thing you need to do is draw in the actual parts for all the bike, for where the bikes go. So I'm going to start off with the first one here, and I notice I'm missing is my height. So I need the height of this point first. So what I need to do is take that there, and I want to apply this height, which is that there, and applying that to all of the individual sections for the bike. So that there goes there, 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 and there. So that's how I get that actual height. Now, I'm going to take them one at a time because it will get messy as I go along. Extend that out there first. So the point on the ground have this point here. Extend this one out here, and finally the top one out here. Now I need to line them up with the opposite side. So this point on the ground at the front is going to be that point there. Follow the line out there. The next one, the actual height here. And we take that across. That line there lines up to here. And then the top point, it's already given to us. It's given to us at this point here. So very simply we can connect that and that together. That gives us the first one. Do the same again with the second one. So we don't need to worry anymore now to actually taking these points across. We have them all taken across. So the next one for the point on the ground, it's going to be this point here. The opposite one on the ground, if I extend it out further, gives me this point here. This line here. Hits that point there. And then the top point, extend that across, gives us that one there. And you'll see that all these lines, they all appear parallel. That's that one there. And the one at the back connects back down to there. That's our second one. Our third one, extend it on the ground here. First of all, we have that point there. Second point, we extend it across, follow it out. It's that point there. Third one, this height here, mark it across, gives us that point there. And the last one is in line with the roof of the shed, giving us that point there. So now I can connect all those together. So that goes to there, that goes to there, and finally this one goes back to there. Fourth one then. Two on the ground once again. That point there, extend it out. That point there. Then I have the front height, extend that out to there. And the top one extends out to the roof there. And those connect together there. And that should be on that line there. I get that point, and this connects back to there like that. And then the last one is going to be this point here on the ground, this point here on the ground, and then the next two, that point there on the top, and the very top point hits the roof there, and that gives me, oh, that should be back. It's very easy to make a mistake. That one should be connecting back to that line there. So that goes like that there, and then this goes back like that there. And that completes part A. So a lot of drawing in that, very easy to make a mistake, but just make sure you follow your lines. The worst thing you can do is take all your lines down at once. You'll just not have a clue how to actually finish it then. Then part B, a line joining Y to B represents the straight line path of a football. Show the point of impact show the point of impact of the ball with the glass roof in the axonometric view. So you can see here, line joining Y to B represents straight line path of the ball. So in the side view there, that's how it looks. That's the path the ball makes there. So the ball is going that direction and hits the roof. The side view exactly there. We'll just say point P. We need to extend that into our axonometric view. So point P, so somewhere along this line here, the ball is going to hit it. So we do the same in our axonometric view. We join B to Y, and we can see the exact point of contact occurs there, point P again. So very simple one there. Just takes drawing 1, 2, 3 lines to complete it. Next one, just take the page off. Move down to A2. So A2, skew lines. We're going to skip this one, lads, because we're going to do skew lines when we're back in class again. Okay, so we'll leave that one for now. A3 then. So don't worry, we will do skew lines in the future. But for now, we'll just go on to A3 here. There's no point in me doing that question out when you haven't done that topic yet. So just get a bit of tape there. Just tape that down. So, A3. The image on the right shows the Salmon Weir Bridge over the River Moy in County Mayo. The drawing below shows the incomplete elevation of the bridge. Part A. The curved support pillar is based on a parabola, which is inscribed in a rectangle. V is the vertex of the parabola, and P is a point in the curve. Draw the parabola. So basically showing you already, side divisions here connect to V, so the bottom divisions are shown there are going to go horizontally across. So the first thing I'll do is divide it up into 5 equal parts for each side, just like the way we would in junior cert for drawing a parabola, and step it out 5 times. So 1, 2, 3, 4, and 5 there. I'll just do this side as well. So 1, 2, 3, 4, and 5. And connect those to the bottom. Oh, and there's one more in here as well. And then the side ones, there's the 5th one there, connect it back down, and then the 4th, 3rd, 2nd, and then the 1st automatically connects back there as well. So all these lines, they'll be going up here. I already have that one drawn. And then the side ones, they'll all connect up to the vertex at V there. What I have is, I have a point here, 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 and finally at the end. And very simply, draw a nice neat freehand curve then as a result. So there's the parabola drawn. Part B, F is the focal point of the parabola, and the point P is anchored to the bridge surface axis by 2 cable stays. The line PF is 1 cable. The second cable is inclined at 25 degrees to a tangent of P. Construct the tangent point P and draw both cables. So the first one is this one here. It happens to be the line I used for my 5 divisions. Oh, this should be connected to P, not to the end. Let's leave that as a light line. So from F to P, there's 1 cable there. And the second one is located at 25 degrees to a tangent from point P. So we know with a parabola, the second focal point is always located at infinity. So what I can do very simply is go parallel to my axis and extend off into the distance there. And somewhere along that line is the second focal point. So it's located at infinity, so it keeps going on and on and on. What I do is bisect the angle in between here to find the tangent. So a line there, there, and swing an arc here, there, and that'll give me my tangent then as a result. So there's my tangent. I'm told my second cable stay is 25 degrees to that. So what I need to do is get my protractor, line up with my tangent, set 25 degrees, and from P, I very simply just go off 25 degrees there, and that gives me my second cable stay. That completes A3. So the last one, A4. that up so you can see it. I'll just tape it down again. So for A4, it tells us the graphic shows a spider cam used for aerial coverage of sports events. It is supported by 4 cables. The drawing shows the projections of the cables. Part A, find the dihedral angle between the planes OAB and OAD. So remember, just like in the 2019 paper, we tried to find out what is common between the 2 planes given. So if we look at OAB and OAD, we can see that OA and OA. So we're looking at this here. We want to find the angle between these 2 planes. There's the line that joins between the 2. So what we need to do is, we need to look in perpendicular to that first. But remember, we want to see it as a true length. If we see that line as a true length, we can look in perpendicular and see the true inclination then as a result, or the dihedral angle. So we go out there and there, and we need to include D and B as they are part of this question. Draw our X1, Y1 line perpendicular to that. And remember, we go 2 views back for our measurements. So I'll just take my heights here first. So the height of B connects there to there, C connects there to there, O to the ground and there, A there to there, and D there to there. So now I have my heights. So the first one I'll take is B here. So that's the height of B. And apply that to there. Give me B. C is my, oh, I don't need C. It's not part of this question. O is that height there. A, this height here. And then finally D is that height there, and D goes from here. So the main thing I need to know is OA. I get an OA there, I have a true length of it. O connects to B. B connects to A. And then D connects to A. And D also connects back to O. But the main thing I'm looking at is OA. I just drawn in the rest just to show it. The main thing I want to know is the true length. And when I get the true length, I can look in perpendicular to that. See it as an edge view. Or sorry, a point view. Draw my second X2, Y2 line. And I want to take out, just mark that as D there. I want to take out OA, B, D. So O and A are out there. D is going to go out there. And B is going to go out there. Once again, going 2 views back. The reason why we know we're going to get a point view now from this measurement here, if we look, O and A are the exact same distance. Therefore, when we look along OA, we're going to see them as a point. So there's O and A. And then B and D. Take the distance here for B. Mark it out here. And take the distance from here to D. Mark it out there. And what you get then is you get your dihedral angle in between there. And the last part, determine the angle between the cables OA and OB. So I want you to tell what is the angle in between there. So basically we can treat that as a triangle there, like a flat triangle plane. What we have here is we have OA and B as a straight line. Can we imagine if we just look at the set square, if I just loosen this and move it up and you'll be able to see. That's like imagine seeing this set square here as an edge view, where it just appears as one line even though it's three sides. And what we want to do is looking perpendicular to that. If we look perpendicular to that, we see the true shape of it, and most importantly we see that angle at the top there, which is what we want to see here. So what we can do is look perpendicular to that there. It's an edge view of our actual plane OAB. So to do that, we go 90 degrees to it. For OA and B, we draw another auxiliary view. This time we call that X3, Y3. And as always, we go two views back. One view back into here, two views back into there. And we get the distance A there. Mark it off there. Distance O there. Mark it off there because O and A share the same one. And then we get the distance from B there. And we mark it off there. And now we can just very simply connect those together. So we have A here, O here, B there. And there's our angle in between that we're looking for. That's our true angle. So hopefully that video helps anybody who may have been stuck on any of those three questions.